With a total of 4,483 hours of printing time on my Prusa print farm, it is time to say goodbye to the Core Ones, because we're upgrading them to Core One Pluses. A cheap joke, I know, but since the Core One L came in and the Core One Plus upgrades are now available for free download on printables, I want to put them on these machines and some other modifications from the community, as well as my own designs, since we now have access to the CAD for the Core One. More on that later. Let's get to working on this. There are plenty of things I want to discuss throughout this video, including that I have a less negative opinion of the new Prusa Open Community license versus some other folks in the community. At the heart, I just want to have fun modifying a 3D printer, something I haven't done on the channel in a while. Quick important disclosure, this video is sponsored by Prusa Research, and Mandic Labs 2.0 is also brought to you by PCBWay. However, the opinions herein are my own, 100%. I was not told to say anything you're going to hear me say in this video, and that'll make more sense once we get to discussing the OCL. Bear with me, you'll understand what I mean. So let's get to this project. I'm sure there are folks in the comments right now saying, ugh, you have to modify that thing. What is this, the Ender 3 days again? The short answer is no. Back in the day, we were having to modify machines to get decent quality or reliable results out of them. With the Core Ones, I've got a whole farm of them for 6+ months now that I've just run as they came out of the box, happily, reliably, high quality, and fast. But at the end of the day, 3D printer companies have to meet a wide range of customers' wants with their products. This thing has to be able to print from PLA to polycarbonate. While I do those things with this machine, happily, for my particular wants and needs, I want to make a few changes to just better suit my use cases. Also, it should heavily be noted that I'm a former custom car builder and a tinkerer. I cannot leave anything stock. Oh, and of course, check the links in the description. You will find listings for all of the community mods, as well as my own new designs that I'm releasing in this video, new today. Let's start off with a couple of very simple community mods, like these printable snap-on corner caps. There's a few points on the chassis of the Core One where it's not as air sealed as I might like for higher temperature 3D printing. One place this is apparent is the top 4 corners of the machine where the press brake bent steel chassis comes together, and there's some gaps there. Those gaps, for most people, are fine. I like to print higher temperature materials, so I want to get rid of them. I printed up these very simple corner caps that I got off of printables forever ago, and I put them on all of my machines. I've used Prusa PETG to print them so they match the orange aesthetic of the machine. There are 3 little clips that fit into the corner holes of the chassis. I find starting with 2 just slightly hooked in and then giving it a good little wrap with my palm will set the 3rd one into place. We've got an upgraded aesthetic, and we can retain just a little bit more chamber heat inside of there for those higher temp materials. There's another one of these air leaks in the spool holder area, this little oval slot that I have no idea what purpose it's supposed to have, but there's another quick, super 3-minute fast print that'll just press in there and plug that up. Next up, while we're already on this side, let's deal with the spool holder. The Core One L has a new bayonet style spool holder that I quite honestly don't care for. What I'm going to be using is a Prusa XL style one. This is a print in place twisted expanding spool holder, which allows for installation of 2 kg and 3 kg spools onto this machine. You have to download the file for the spool holder and then the adapter to the Core One separately. That's this little disc here. Installation will require a single M6 by 75mm screw and a T-nut. The T-nut presses into the back of our adapter, and then the screw passes all the way through the inner twist section into that T-nut, sandwiching everything together. This is a solid little design that installs in place of the original side spool holder using the original holes in the side of the Core One. And thanks to the internal design, you can unspiral the spool holder and put on 2 kg spools. With the spool holder managed, I want to plug up one last set of holes. The fans on the back. These are chamber temperature regulation fans. They work in conjunction with the top vent to draw fresh air in and keep the internal temperature of this thing down when printing materials like PLA, PETG that don't want a warm environment. But once again, I like to print higher temp materials, so I've just got gaping holes in the back panel of this machine. It still achieves solid chamber temps with that, but I think we can help it out a little bit. Around those fans, there are 4 mounting holes here. These are for mounting the advanced filtration setup, the charcoal and HEPA filter system. What we're going to be installing is vent flaps. This is a printable frame and 4 flaps. Let's get it installed so it'll make more sense. Assembly and installation is very easy. You take your frame with angled vent flap slots and just set the vent flaps down into them. Then once you have all the flaps together, carefully take it to the back of the machine and use 4 M3x10 screws to screw it on. I do say carefully because due to the angled design of the vent flap slots, if you turn it too much, they fall out. It's as simple as that. When the fans turn on, the flaps open. When the fans turn off, they automatically close. Now we will test the chamber temperature of this thing pre and post modification later in the video, once we install the custom internal charcoal filtration system I designed for this. We're gonna get to that after we do 1 or 2 more simple mods. One place I do feel like the newer Prusa machines could be improved is in their hot end cleaning operation before a print. That is pretty critical as they do nozzle probing for Z-homing, offset, and bed leveling. So making sure that tip is good and clean before it gets going matters a lot. Currently, they warm up the nozzle, peck it against the bed to clean it off. It works, but it's not the most reliable. So in comes Stealth Brush, a design I found on printables that uses a silicone wiper in the front middle of the bed area and has a really nice stealthy angular look to it that I think both fits the Core One and my personal aesthetic well. There are single and multicolor file versions, so I printed the multicolor one on the Prusa XL with Prusament PC Blend for the black main frame as it's right against the bed that I often run at high temperatures, and Prusament ASA for the colored sections of the Core and One. Assembly requires installation of some Voron size M3 heat inserts. To install this, we're going to put it onto the front 2 Z-axis arms for the bed. There are a pair of M3 sized holes in those, so we can come up through the bottom of the arms with some M3x8 screws. The printables listing also has some start G-code you have to add in the slicer to get this operation running so that the printer will know to go to this area and wipe across that brush before a print. With our nozzle clean, it's time to get our hands dirty. We need to pop some panels off and get inside of this machine to start modifying it even further. First things first, I had to pull these push pins out of the side panel so we can get this panel off. That's going to give us access we need to install a USB cable in here. Currently, if you buy a Core One, it comes with the USB cable pre-installed. That will be to power an add-on camera. As the Core One doesn't ship with the camera, they have the Prusa Buddy Cam that you can add into here, and that's what they intend you to plug in with that USB cable. But I'm not going to be using the Prusa official camera. We're going to be using a community mod that lets us use the Seed Studio S3 Sense. This is an ESP32 Wi-Fi connected webcam. The reason we're going with the S3 Sense instead of the Buddy Cam is honestly down to economics. S3 Sense, if you buy it direct from Seed Studio, is only $13 pre-soldered. As I've got a bunch of machines, I need a bunch of cameras, so the economics really came into play. Though, full transparency, I did reach out to Seed Studio and they provided all the cameras I'm gonna need for this project. So thank you to Seed Studio. You can find an affiliate link to them in the description if you wanna pick up one of these cameras. Assembly and installation is straightforward. Camera module snaps into the front housing, the rear housing has some magnets pressed and glued into it, and then that just all assembles together into the corner of the Core One. That said, I have a couple of words of warning about this particular mod. Seed themselves told me they're a little concerned these cameras might overheat in the warm environment of this printer, so only time will tell whether or not it's reliable for my uses. Setting up Prusa Connect's firmware for the ESP32 cam is not fun. It took me a handful of tries to get each one that I set up to actually work properly. I do have to say, if you only have 1 or 2 machines, I would probably really recommend just spend a little bit extra and get the Buddy camera, because that was a very easy setup in comparison, and I know it's been working reliably in the Core 1L with good hot chamber temps. With our camera installed, we are in the home stretch, though we have at least one big thing that I designed for the Core One yet to come. But first, I want to get the Core One Plus upgrades done and talk a little about the Open Community License. When Prusa launched the Core 1L, a few improvements came along to the quality of life of the machine that they backported to the Core One. So now it's the Plus variant. If you buy a machine today, the basic Core One will be the Plus version with these add-ons. Or if you already have one of the older machines, you can download the files for free on printables, print them yourself, and upgrade the machine. Along with that, Prusa released the CAD for the Core 1 and L versions right around the same time under the new Open Community License. And I have definitely heard some grumbles about how open that license actually is, and I'd like to discuss that a little bit with maybe some spicy takes, I guess. I get that the Open Community License maybe sounds misleading to some folks who feel that it's not truly open source, so it shouldn't have open in the name. But then you've got Creative Commons non-commercial licenses out there that are commonly used on projects like VZBot and Mercury One, and I don't hear the same anger there. For me, as a small business owner using these machines to make my livelihood, the Open Community License allows me to repair and modify my machines to my own wants and needs perfectly fine. I just can't turn around and then sell the things that I produce, which is not something I want or need to do. There's so many companies out there these days who would gladly take the R&D, the hard work that Prusa has put in for years, turn around and spin up clones with none of the R&D costs associated with that, so they can undercut the prices and put Prusa out of business in the long run. Unfortunately, those companies don't seem to really care what companies they leave in their wake. They'll move on to the next open source project that they can take advantage of. Meanwhile, we have other companies in the 3D printing world who are gladly taking GPL3 software and hardware, patenting it, or just using it with violations to the license, such as not releasing source code or properly attributing it, or closed source ecosystems entirely where we can't do anything we want to make these machines our own. And it feels like such a strange thing to me that some folks are so vocal and angry at Prusa for trying to make 3D printing work for them in 2026 and being as open as they feel they can be, but they're getting more backlash from my perspective than some of these other companies that are genuinely bad actors. I've got a machine that I can upgrade the filament sensor on so that I can easily feed flexible or rigid materials that want to break going through any type of restriction through with a switch of the sensor now. I got a machine that can now open and close the top vent for ventilation with cents worth of plastic printed parts. I love open source projects. I'm wearing a Voron shirt right now. It's not the one that says proudly selling nothing. That might make my point a little bit better, because the reality is 2026, trying to make a business where you need to pay hundreds of people for support, R&D, business operations, have a roof over your head. I, as a business owner, am intimately familiar with all of that goes into running a business, and it's just me in one space. And I feel like a lot of people lose sight of that and want to stick to an ideal more so than a reality of day-to-day life in our current world. For me, the OCL means I'm now free to make my machines exactly what I want them to be for my own business needs, and you folks will be able to download the designs that I produce to go along with that for your machines and your wants. And I don't see the negative in that. Go ahead and flame me in the comments. For now, I'm going to get to installing the modifications that I designed for this machine. The Core One is decently lit with a single LED strip behind the front cross member. However, it is a black box inside, and for my filming purposes, I want a little more light. So I designed up some printable LED strip mounts. These are 125mm and 250mm lengths, depending on how much light you're trying to shine on things, and they accept your standard adhesive-backed LED strips, whether it be RGB ones, which you'll need an additional controller for, or in my case, I'm just going with some 24-volt, high CRI, white light LEDs. These accept 8mm magnets in the back, the same size as the camera mount that we used earlier. So they hold really nicely, and with the steel structure frame of the Core One, they can magnetize onto it. I specifically designed these to fit this structure so that they nestle nicely up into the 45-degree corner to shine down into the print volume. I also designed a wire tie that has a single magnet in it that can go into the corner and cable manage a little nicely. But then I used the underside of one of these side rails where the filament sensor wiring is to run the wire back to the back of the machine, then across the back wiring channel and down to pick up 24 volts where the power feed for our buddy board is. This does mean my LEDs will be on anytime the machine is powered on. They won't be controlled by the screen controls. Is potential you could jump off of the end of the LED strip that's in the machine. That's a do-it-your-own risk kind of thing. Then you would get control, but I wanted fixed light. I don't ever adjust the brightness, so I'm not really worried about that for my needs. It's not a big difference. It's just a little more fill light into the inside of the chamber, but it helps to cast some light where there were shadows previously. Earlier I mentioned the Prusa Advanced Filtration System, a HEPA and charcoal filter setup that we first saw in use on the Mark IV enclosure. In there, it circulates the air through the chamber, filters it, and helps to equalize temperature. However, on the XL, Core One, and Core 1L, it's still in use, and it does filter the air, but then it expels that filtered air out into the surrounding environment. And I don't particularly care for that. In the aftermarket and open source world, we have a couple of options like the Nevermore or the Bento Box, which are add-on filter setups that keep the air inside of the chamber, giving the filtered air a chance to be filtered again. It can be exchanged numerous times, so stuff that wasn't caught the first time through might be on subsequent passes. I want to get my design installed into the side panel of this machine, so let's get to assembling it and we'll talk design considerations as we go. First and foremost, I wanted this to be able to be printable on the Core One. So I did split it into smaller chunks than I might have necessarily wanted to, so that they could fit this print volume. There are 3 pieces of hardware needed for assembly: 6mm by 3mm magnets, M3 boron-sized heat inserts, and M3 by 8 screws. The design of this filter assembly was my hyper-fixation for this entire project. I spent far too much time on it. I thought it'd be a quick, easy thing. It turned into multiple days of design time and more than one all-nighter. But it's that thing that I just couldn't help myself from having to do on this particular project. Assembly is split into 4 parts in the Core One printable version, as well as a couple of cross-member pieces, like this fan mounting bracket for 40/28 server size fans, or 40/20s with the included 8mm spacer like I'm using here. The side panel that will actually mount to the machine is simple flat plates that print separately and then get screwed onto the back of the entire filter main body housing. There's a wire channel in the fan area that runs toward the back to make for a clean wiring run. The actual filter housing is a multi-stage charcoal filtration setup to separate out the charcoal so that it's not just packed all the way through this entire thing. This top flange closes off the top a little bit. It's really to mount the HEPA cartridge mount, this snap-on magnetized top piece that accepts a pair of robot vacuum filters, same as the Bento Box. On the back side of the housing, where you won't really see it inside the machine, is a couple of bosses to mount a PCB onto to make fan wiring a little easier. When properly installed, the filter housing will actually sit down into a pair of rail grooves on the sides, magnetized down to the fan mount on the bottom and to the sides of the housing so that it won't rattle. And then this honeycomb grate goes on top, which also further ties everything together to prevent rattling. And with that, I present to you the HIVE filter. High efficiency, internal VOC eliminator. Any good design starts with goals, and I had a couple with this project. Obviously, filtering the air inside of the Core One without dumping the heat out of the chamber was number 1. But number 2 was maintaining the internal volume of the machine as best as I could. The Core One's unique design with the kicked-in side panels reduces the internal air volume that needs to be warmed up to maintain a high chamber temperature. So I wanted this design to not have a bunch of dead space that would have increased that internal air volume. It would have been easy to put a flat side panel on and just throw in whatever filter I wanted. That wasn't my goal. And the last goal was to even out internal chamber temperatures by drawing in warm air at the top, filtering it, and then with the guided ducting at the bottom of this thing to kind of disperse it all around the bottom of the chamber, hopefully keeping the temperature more equal from top to bottom inside the machine. An important note, I'm wiring this to the external fan port on the buddy board that's intended for the advanced filtration system. I did have to install a buck converter to step down 24 volts to the 12 volt fans I'm installing. I had a really hard time finding any 24 volt 4-wire 4028 fans that were reasonably priced, so I went with these Arctics I was able to buy in a multi-pack really reasonably, 6,000 RPM, only a 0.1 amp power draw, and not too loud. And I'm going to go ahead and install those into the single piece version of the filter housing. Now I did go ahead and fully assemble and put together the Core One printable version of this to ensure that everything fit as I intended it to, and it does. I was able to install it into the machine and everything. But if you have a machine with a 300 or bigger build volume like the Core One L or the Prusa XL, then you could print a single piece version of this housing that doesn't require as much hardware, connections, and doesn't have the lines breaking it up. And while I did assemble the setup with the printable side panel pieces that print in 4 separate equal size pieces, I decided to go with a cleaner setup. I created a single piece design to be cut out of metal by any laser cutter like studio sponsor PCBWay. I went with 14 gauge steel for mine. This is definitely overkill, 16 gauge would have been fine. But this allows me to have a cleaner overall look for my studio environment and a more solid design with less possible gaps between sections, and it honestly installs a little easier too. The printable ones are just on the edge of thickness that the plastic rivets that hold this panel in can grab. The metal one can be thinner and stronger, so it works better with the plastic rivets. With that panel installed, we have a rock solid mounting base for the HIVE filter, or whatever mod you might want to design for the side of the machine. Auxiliary part cooling maybe, or an active chamber heating setup. There's plenty of options for what could be mounted to this. It's a blank canvas to build upon. That said, if you order just one of them from a laser cutting service, the economics aren't the greatest, which is why I ordered enough for my entire farm. It got the price per unit way better. But that said, I'm heavily considering offering these as a product in my shop, and I could get them cut in batches to get the price way better and powder coated to match the machine. So let me know in the comments if that's something you'd be interested in, because I'm really considering that as an option, as well as maybe a hardware kit so you could build a HIVE filter for yourself. Now that mine's built and mounted, it's time to get to finally testing all of our mods and seeing if we achieved the goals I set out to achieve. Straight out of the gate, I'm happy to see the airflow coming out of the HIVE filter seems to be pretty evenly distributed around the bottom of the chamber, and that was definitely a goal. So the million-dollar question, how about temperatures? I mean, that was arguably what quite a few of the mods were focusing on. To test this, I put a couple of K-type thermocouples in the chamber, one at the top, one at the bottom, so I had independent readings. I preheated the chamber from ambient, which was just over 1 degree different in our before and after testing, for about 15 minutes on the ASA setting. At the end of that testing, we had about an 8 degree temperature difference from our before mods to after mods. That's pretty dramatic in just a 15-minute preheat window. But what about while actively printing? That's quite clearly the more important readings, right? Well, I sliced a benchy with Prusa ASA. It's about a 20-minute print, pretty short for a high temperature print, but it should be representative of our improvements. During that print, on the after testing, the HIVE filter was running at about 60% fan speed, so circulating air continually through the chamber. Immediately after the print was finished, I checked our temperatures, and here they are. Not nearly as dramatic of a difference at the top of the chamber, but a pretty significant one at the bottom, which is going toward what I was hoping to see. more even chamber temperature distribution, and I most saw this during the active print. As soon as the print finished, the temperatures actually swung pretty wildly. While it was actively printing, I checked it, and this thing was running 44 degrees at the top of the chamber and 43.1 at the bottom. Less than 1 degree difference across a non-actively heated chamber is pretty great in my opinion, and I was thrilled with that result. The Hive is absolutely doing what I would hope it would do, moving the warm air throughout the chamber, so those higher temperature prints should be more stable. As far as VOCs are concerned, I don't have any good method for testing that currently, like parts per million or anything like that. I can just sniff test it. To my nose, the before and after testing, the carbon filter is absolutely doing its job, and really there's quite a bit of carbon in there, really moving air through the chamber. Those temperatures are showing us we're circulating it nicely, and I didn't really detect an odor at all standing a few feet away from the machine, which is exactly what I was hoping to see. This machine used to get pretty stinky printing ASA because there was just no air scrubbing at all. So now I've got a Core One that's achieving better chamber temperatures. It's getting the air cleaned with that HIVE filter. It's got a camera to preview things, a nozzle scrubber. Plenty of quality of life improvements have been made, and I am thrilled about it. What I'm not so thrilled about, I have to do everything you just saw 6 more times and convert a Mark IV to a Core One with these mods. All the mods that I've shown you here in this video, mine, the rest of the community mods, you can find links to in the description so you could use them on your machines if you wish. Were they super worth it? Well, I did over 500 hours of printing since the beginning of this video. I'm right around 5,000 hours on my entire farm now. It's a lot of prototyping time, it's a lot of printing, especially when it came to the HIVE filter, to get all of the designs done. Is it worth it? For me, yes. I'm loving the way my farm has been running, and I'm looking forward to getting all the machines updated in the same ways. Is it going to be worth it to you? I can't say. But I'm really looking forward to what the OCL is going to bring as far as new remixes and mods and things coming down the pike now that folks have access to the CAD. I can't wait to see what the rest of the community does. If you want to see more videos of modifying 3D printers, check out my second channel, Mandic Labs. I'm going to be doing more of that on that channel in the very near future. So do get subscribed over there if you're not already. All right, folks, that's where we're going to wrap it up for this one. Let me know in the comments what you thought of these mods. If you're interested in the HIVE filter parts or the side panel, find all the links to the mods in the description. Hope you found this one interesting, folks. Do get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See ya, folks.